or something. I largely study ego networks. I've done some work in sociocentric, but I really prefer ego network methodology for the kinds of questions that I ask. So I'm going to talk to you today about advances in ego network methods for health research, or just random shit we've been up to these days. And so hopefully some of them will be useful. So I'm going to sort of start with theory, because that's generally where I start. And then from that, think about what are the kind of methods that I need to use to get the sort of data that I want to test the theories that I want to test, right? So I'm going to start at like kind of a high level with all the data that I'll be showing you today is from a study that I'm currently doing on essentially social networks and Alzheimer's disease. So what are the social and biological mechanisms linking social connectedness to risk for cognitive decline and rate of cognitive decline once you've been sort of identified as high risk or diagnosed with mild cognitive impairment. So social connectedness and ADRD, there's this really strong link between measures of older adults' social networks, social connectedness, sort of variously and heterogeneously defined and measured, and the onset and course of AD dementia. There's a ton of prospective longitudinal evidence at this point, decades of research. There are multiple meta-analyses now. But of course, two things are sort of missing from this literature, in large part because the research has been driven to this point by people who are neurologists, who are working in biomedicine. Sociologists have largely been sort of absent from this debate. So it's not really clear what those actual mechanisms are. So when we're talking about different kinds of measures that are used in the literature, it's things like number of relationships, frequency of social contacts, perceived support, social isolation and loneliness, social activities, marital status. I mean, just like sort of runs the gamut. So this doesn't really tell us anything about what is the actual social mechanism. What is it about interacting with other people in a particular kind of network that's associated with better cognitive health long term? And there's also sort of an absence of a unifying theory of social risk and resilience in this literature. So we sort of set out to try to figure out what is it about social interaction that's beneficial for your cognitive health. And so we started out by thinking sort of broadly about the like classic social networks literature and what you get or the sort of harms that can come to you from being embedded in particular kinds of networks and relationships, and then sort of merge that or integrated that with the ADRD, Alzheimer's disease and related dementias literature about what are some of the risk factors for ADRD pathology and cognitive decline. And so we sort of came up with this sort of like broad overarching theory of what might be going on. So, we're interested not only in sort of the social mechanisms here, which are sort of the first set of little boxes, but also, we're interested in upstream social determinants of those downstream networks and even further downstream, the biological mechanisms that put you at risk for ADRD. So of course, in order to test something that's as complicated as this, we need a lot of data and we need the right kind of data. So if I just went out and asked, the important matters name generator, for example, is that really going to get me the kind of data that I need to operationalize social bridging or social stress or social influence, right? So you have to think really carefully at the outset about the kind of data that you need. And so that's sort of what we've been doing, and so I'm going to share a little bit of that. So today I'm going to talk primarily about two of these mechanisms, social bridging and social bonding. So social bridging really ultimately, in terms of its benefits across sort of a variety of different substantive applications and contexts, really comes down to novelty, right? So we can think about Coleman's bridging and bonding social capital, of course Granovetter's strength of weak ties. What are we getting from these weak ties that we don't get from strong ties? Burt's structural holes and sort of the management business context. And it's this idea that we're getting something new from ties that we're not, who are not all connected to each other, right? So something about being in a network that's bridging-esque, right, or having access to these bridging ties brings new things. And this is a really nice fit for one of the theories of cognitive resilience in ADRD. It's called cognitive reserve. And so to date, this has largely been tested in terms of things like education or occupational complexity. But the idea generally is that we have these enrichment experiences over the life course that provide these degrees of reserve or resilience against neurodegeneration. It's really cool because you can look, I'm super into brains these days, guys, like really into social neuroscience. So these are 3 pictures of brains. This is actually amyloid burden. So the reddish orangish is bad, right? That means you have these proteins in your brain that are associated with ADRD and cognitive decline. But what's interesting is that, so the person on the left is amyloid positive, the person in the middle is amyloid positive. The one on the left has Alzheimer's disease, but the one in the middle is cognitively normal. So your brain can be real messed up on the inside. This is my sociology way of talking about it. But actually your cognitive function is like totally fine on the outside. And so we would say that the person in the middle has cognitive reserve, right? So what is it that builds this cognitive reserve? And we think that access to novel social stimuli through these bridging resources might be one of the things that helps build cognitive reserve. And then on the flip side, this is my very happy lesbians picture. I got it on the internet, but that's not what I Googled to find it. But I can say that because I'm a lesbian. So, but anyway, I digress. So social bonding, really what that comes down to is security, right? Like it's all about feeling secure, getting positive, happy resources, getting support. So this is, of course, like bonding social capital. It tends to occur within networks of people that are like us, that have the same opinions, that are reinforcing, all the things we believe about the world, making us feel good about ourselves, making us feel like, we're a happy part of a group. Stress buffering, all these things, right? So this is sort of the flip side of bonding. And there's, a nice biological theory for this as well, because we know that stress is really bad for the brain. So bonding social capital could be operating on ADRD through neuroendocrine regulation, right? So we know that these social experiences help regulate hormone production and the way those hormones are metabolized, and that's associated with cognition and memory. And it can, there's a lot of studies that sort of social support or like a lack of loneliness or integration reduces the neurodegenerative effects of stress on the brain. And so we have this sort of nice biological mechanism here too. So what we've done in this study is use personal social network methods to try to disaggregate these sort of distinct dimensions of social connectedness, right? So the great thing about networks is you can really get in there, get lots of information about these individual alters, and then use it to create really like dozens of different kinds of measures of social bridging, social bonding, social stress, et cetera, et cetera. So that's what we're doing. You guys already know how to do this, right? I don't need to, okay, perfect. So that's what we do. But then, okay, you're on the other side of this. You've collected your data. So we did the data collection in 2 phases. We had a phase 1 where it was pilot data. We didn't have a lot of money, so we collected smaller networks. And then we have a phase 2 where we collect like a shit ton of network data. I'll tell you like momentarily more about that. But then when you have this shit ton of data, you have too much data, right? You have too many measures. So how do you decide like what's the measure of social bridging or what's the measure of social bonding? It's really hard, right? Because they all sort of operational, like even the theories are not that clear. There's like 4 different theories that are kind of saying the same thing, right? So like what is it exactly about these kinds of interactions that make it bridging or bonding? And then it's even more complicated because it's almost like 2 sides of the same coin, right? So like if you have a network that's made up of largely kin, that could be bonding, but it could also be low bridging, right? So shit, what do you do with that? So this is kind of what we've been trying to deal with analytically over the past couple of years. So these are the types of measures that we've created using our network data. So for social bridging, we're using things like network size, proportion of non-kin, effective size, density, soul bridging, which is when you're like a bridge between 2 people. It's like a binary indicator. Minimum tie strength, so like essentially what's the strength of your weakest tie. Diversity, which is role diversity present in the network, and then heterogeneity on like a variety of different kinds of indicators, race, gender, education, age is really important for older adults, turns out. And then on social bonding, we have a lot of these measures that we're creating from the network measures, but then we can also bring in like subjective like relationship quality like sort of measures, right? Or perceived social support measures. And so, we have these kinds of things as well. So like how often are you in contact with these people? We have support multiplexity, so how many different kinds of things do these people do for you? We have like a closeness variable and a tie strength variable. So lots and lots and lots of data, right? So which of these things do we use? How do we sort of boil this down to something that's manageable that we could throw in a regression model. Oh, yeah. So this is kind of like the oof, what a mess. So I created this. It's really ugly, which is how you know I created it, not one of my students or postdocs. But essentially it shows like, you know, these are our different theories here, and we have these different measures of these theories. You know, we have like just a ton of data. So what's the best way to show this data? This is probably not very effective because I'm guessing you're looking at this and you have no idea what it says. I mean, sort of in brief, the green ones on the right are social bridging, and those all almost all matter, right? Almost none of the other things matter, like bonding almost never matters, et cetera. And this is for cognitive, general cognition. So yeah, so can we do better than this, right? Can we do something better than this? So what we've been doing, and I was kind of skeptical that we could actually do this, like actually, you know, operationalize a latent variable in a way that like latent variables are supposed to be operationalized, as you know, which means like you have this like shit ton of messy measures, and then you can actually get something which like reflects a theory in a really nice way. And it turns out you can do that if you have big enough networks, and I'll talk about that in a minute. So that's what we've been doing, is using a latent variable approach in structural equation modeling, but we also have done the thing where we create the latent variable and then we just use it as a variable in regression models or other kind of models that are used in neuroscience where you can't do all this like fancy SEM and things. So this is like just one of the models we've used. It turns out you can like move different measures in and it doesn't matter that much. Like you tend to get sort of the same outcomes, which is really nice and tells me I think that we're operationalizing theory in a way that's relatively robust. And then you get these like nice measures. These are in standard deviation values, and they're like relatively normal. So like you see this and you're like, oh, this is exciting. I can do something with this variable. And that's kind of what we've been doing, is doing things with this variable. So in the bottom you'll see like little like credit to whoever the first author is. I have the most amazing postdocs and students ever. So this is just an example. We started out with this latent bridging factor, which was actually based on our pilot data, which are much smaller in terms of the number of name generators we use. The average network size, I think, is about 6. And so then we can use confirmatory factor analysis through SEM. And this is just what the average networks look like. These are network ideal types. When bridging, the latent bridging factor is below the mean versus above the mean. And you can see that they look different. All the stats look good. So we're like, great, let's go forward with this and see what we can do with this latent bridging factor. And it turns out we can do some really cool stuff. So like this is a voxel-wise regression analysis of the relationship between social bridging and gray matter density in the brain. So we can do this. This is not something we could do with SEM, right? If you can imagine, if we tried to do this, picking a single measure, like what would we pick, right? Would we pick network size? Well, network size can mean like a million different things. And it's almost like not meaningful in ego networks, right? Because it all just depends on who you're asking them to name. So this bridging measure just like performs super well across a variety of different analyses and contexts. So this, for example, shows that social bridging is really strongly related with gray matter density, which means like you have a nice fat plumpened brain, which is what you really want for your cognitive health, in areas of the brain that are responsible for social cognition, like the amygdala. So this is what we want to be able to see. It's also really useful for mediation. So we found, for example, that social bridging, this latent factor, mediates almost 30% of the relationship between educational attainment and cognitive function and cognitive decline. So we can look at things like disparities by using bridging as a mediator. And we've done this, we've found something similar for rurality. Also, I have Adam Roth. Oh, you guys might know Adam Roth. Sorry, he was in this thing for a while. He's great. I met him here, actually, so, and then I hired him, and he's done wonderful things. Anyway, so more recently, so we started with the latent bridging because when we were looking at, obviously, like sort of that first really messy graphic, you could see that it was really the bridging things that were popping up, right? So we're trying to figure out, like, you know, we have bridging's great. What about bonding? What does bonding do? So recently we've started looking at latent variables for bonding as well. And what's interesting is that they're like pretty highly negatively correlated, right? So on the bottom here, On the x-axis, you have bridging capital, the latent factor, and then the latent factor for bonding is on the y-axis. And they're pretty negatively correlated, which suggests there might be some sort of trade-off, right? Which of course fits with a lot of the evolutionary data on, what kinds of networks are we putting our energy into. And there's also some really interesting theories about social networks in the life course, wherein like early in the life course, we really like put all our eggs in the novelty basket. And we like to like meet new people, get new information, because that's what's like sort of good for us from a survival standpoint, and like meeting a mate and having kids and things. But then older adults tend to sort of go all in for more of the bonding. This is called the socio-emotional selectivity theory. And so they start to sort of prune their networks and really focus more on establishing a sense of security as they see sort of death coming, right? Like they're like, I'm about to die, I only want to hang out with people I like. Which is how I feel now, so. You what? Oh, yeah, right, yeah, exactly, which is like two of you. It's like me and Jim, basically. But anyway, so this square here represents one standard deviation above and beyond for each. So you can see there's a lot of people who are sort of in the middle, right? They're able to cultivate networks that are sort of bridging-ish and bonding-ish. And so we've been looking at that as well. But what's really cool from sort of a theoretical perspective is that the health effects of these bridging and bonding networks are quite different, right? So if we look at, these are like a variety of cognitive indicators here. So the blue ones are bonding, and the red ones are bridging. And if they're sort of darker, it means they're significant. We need to, well, I don't know if it's a not bright screen or if we've done a shitty job of coloring the squares. But anyway, so this is MoCA's general cognition, attention, speed. We have a whole like shit ton of measures of cognition. So you can see that bridging, by and large, is beneficial for cognition. And executive function, memory, and language are really important because those are sort of like three of the things that go first in ADRD. And bonding doesn't matter at all for cognition. But then if you look at mental health, right? So this is where I think theoretically it's really interesting to think about what our measures mean and what they get us in terms of health, right? Like what are you buying in terms of health? And you really have to understand the measures that you're using in order to link them up in a coherent way to theory. So if we look at mental health, it's really the bonding that matters, right? So higher bonding is associated with more happiness, perceptions of support, lower depression, lower levels of loneliness. Whereas bridging doesn't matter for mental health. Sure.
Are those items at the bottom different components of the MoCA? Or the other?
They're different measures. So the MoCA is like, I don't know, you must know something about ADRD. Yeah. So the MoCA is like this general cognitive thing. It's actually the test that Trump said he got a perfect score on. But it's, yes, it's literally like, here's a picture of a lion. What is this animal? Like it's a very general like cognitive screener. Or like there's a clock, and it's like, what time does this clock say it is, right? So this is not like genius level questions. But anyway, it's very good, but it's also sort of like a blunt screener. So these are like sort of gold standard, diagnostic, clinical diagnostic measures of these things. So that's good to see that there's some consistency across those. And then we're also able to do longitudinal analyses of these bridging and bonding latent factors, which of course would be even more complicated if we were trying to use multiple measures of bridging or multiple measures of bonding simultaneously. We don't have to pick. We have these beautiful latent variables. And so we can look at things like, okay, this is what the bridging level is at the initial visit, and then how does that change over time? Well, bridging and bonding don't change on average over time across the sample, but you can see that there are these pathways, right? So there are like pretty significant variations across time in the study in bridging and bonding. And then we've, I don't remember, I didn't put that slide in here. And then we've used lagged fixed effects models to say, do changes in bridging and bonding associate with changes in cognitive function? And they do. To a lesser extent than sort of the cross-sectional model, because we're still like sort of low N at this point. But we're seeing longitudinal relationships that we want to see, so that's really good and exciting. And then we can also create network typologies, right? So I mentioned earlier that there's these, there are these people sort of in the middle that seem to have kind of a mix of bridging and bonding. What our postdoc Lucas calls balanced or non-dominant networks in terms of non-dominant bridging or non-dominant bonding. And so these are sort of the, he used k-means clustering to identify the typologies. Three groups, 3 clusters was the best fit, which I think is really exciting because that's kind of what I would assume based on this. And then we have now these typologies, and this is sort of what those typologies look like on average. And we can use those in analyses, and we can also sort of check ourselves, right? So like if we're finding this with the continuous bridging and bonding, are we also finding that these typologies matter in the same way that we think they should? And interestingly, what we find is that, so the bonding focused are still really good for mental health. The balanced don't confer any mental health benefits, but they do confer some cognitive benefits. So the balanced cases look more like the bridging than they do like the bonding in terms of how they perform. So there is kind of a trade-off, it seems, right? Which is kind of sad, I guess. I don't know. I haven't really thought much about it. I literally just got these results like 2 weeks ago. Anyway. Okay, so that's sort of what we're doing, right, and why we care about identifying these networks well. And so I'll talk a little bit about sort of core versus peripheral networks. So somebody over here mentioned, like, well, I have these really small networks. What can I do with them? News is not great, guys. So I mentioned that we had sort of 2 phases to the study. So phase 1 was this pilot where we were going into the clinic, and they gave us like 20 minutes. So we're like, shit, we have to collect network data, plus like some other things that we want in 20 minutes. This seems really hard. So we used kind of the classic core network name generators. So we used important matters discussants. We modified it a little bit. So rather than just saying, who do you talk to about important matters, we ask, who do you really trust to talk to about important matters? Who can you count on when you have important problems? So we kind of modified it a little bit to really like go all in on the core aspect of it. And then we use important matters regulators, which is who talks to you about your important matters, whether you want them to or not. Always women. Usually moms or partners, turns out. And then burdens, we tend to drop these. This is who talks to you about their problems, whether you want them to or not, right? And then we do the same for health matters discussants. And we've used these a lot in other studies, and so it gives us sort of a basis of comparison, which is why we chose these. So that was the phase 1 pilot. And you can do a lot of cool stuff with these networks. But once we sort of started to realize that bridging seemed to be the mechanism here, we're like, we really need to look at bigger networks, right? So like when we say bridging, how much bridging do you really need? We knew we weren't really going to capture bridging with these pilot data because our average network size is like 5 or 6. And so we wanted to try to go bigger. And so some of you, I'll talk about that in a minute. So we added a bunch of name generators. So we used the pilot ones, and then we added, basically we were looking for regular interaction partners. So the qualifier was always, people that you talk to somewhat regularly, I think was like the qualifier that we used. So we want family members that you talk to somewhat regularly, coworkers or fellow volunteers, neighbors, anyone else you haven't mentioned, the study partner. If they haven't mentioned, we have like all this corroborating data from informants. That's a whole nother thing. And then we added this elastic ties question. So I'll talk about that more in just a minute, sort of delving into what those look like. But this was kind of a nod to like the Matt Desmond, Mario Small, and Stacy Torres type of networks. This idea, I think Jimmy may have talked about this earlier, right? So this is the idea that first of all, important matters suck for sort of, it tells you a lot about who you may regularly interact with, but if you really are interested in who are the important people you're talking to, that sometimes we get that from weak ties, people that happen to be there. And so we added these, and I'll tell you a little bit about what we found here momentarily. That's like a teaser. We ended up dropping it, actually. That's why it's in red. So the data you'll see now, we used it for a little bit. It was a pain in the ass. And then we dropped it after some analyses. So I'll tell you about that in a minute. So if we're looking at sort of the ideal type, this is based on average network characteristics by consensus diagnosis. This is what they look like. And so we have people who are cognitively normal, mild cognitive impairment, and then people who have early stage or moderate dementia. And you can see that there are these like pretty decent sized network differences. But again, if you're dealing with small networks, It's like, well, what is this really capturing, right? So like how different do like the larger peripheral networks look like? And so they look pretty different. So we see much, much larger average differences across diagnosis for whole networks relative to sort of the pilot like core networks alone. And so, this is what someone with MCI or dementia looks like here on the right, on average, using sort of all those name generators that I mentioned. And then on the left, this is what an older adult who's cognitively normal looks like, which was really interesting and a surprise to us because these networks are actually much larger and less connected than we would have thought they would be for older adults, given sort of the theories that I was just telling you about regarding socio-emotional selectivity and, honing in on the stronger ties as you get older. So when we're talking about measuring bridging, you get a lot more bang for your buck, a lot more variation when you have larger ego networks. So going back to these elastic or durable or incidental, I think Matt Desmond calls them disposable, which seems really mean. Especially because he found that these people do super important things for you. So anyway, so the way that we actually asked the question, and this was kind of a methodological experiment really, we had no idea what we would find with older adults, but we asked name the people you talked to for at least 5 minutes and then we randomly, we picked the weekday before so that recall wouldn't be as bad. And then the people you talked to for at least 5 minutes on the last weekend day, whatever that was. And then we looked to see, well, how unique are these ties versus sort of all the other name generators that we included. And so this is just like the frequency here. These are essentially alters, right? So 1029, 1029 were not these incidental weekend ties. 271 were, but they weren't unique, right? So in other words, they were picked up in some other name generator. But then it did elicit these 171 or 12% of ties of alters that were unique, right? That we didn't pick up these other name generators. Weekday ties picked up less, right? And so I don't know what you would find if you weren't looking at older adults, because a fair number of these people are retired. But I think they're seeing sort of more different people on weekends than they are on relative to weekdays in terms of unique from their social network. And then you can see sort of the average closeness and density of these ties. So we're like, okay, this isn't that many alters, right? We're not getting a huge number of additional alters with this name generator. So what is this telling us with respect to prediction? Because that's what we really care about, right? So there are sort of two things to pay attention to in this really ugly table here. And one is, so these are sort of, I can't go past this line. These are the comparisons of network size and the network size with the elastic ties dropped. So we just essentially recalculated the network, all the network measures with and without those ties. And so you can see in predicting MoCA, which is general cognitive function, and then episodic memory, which is one of the most important for ADRD, that they look almost identical, right? So the correlations are very, very similar. So you're not getting a lot of predictive power here, even for measures of bridging that are typically pretty robustly associated with these outcomes. So we're not seeing a lot of difference. This is mean closeness, and this is the density of the network. And so then the red is the correlation between the two, right? So how correlated is that measure if you include it with the elastic ties and without? And they're pretty highly correlated, especially density, right? So if you care about network structure, which of course we do for bridging, they end up being very similar. Okay, so we dropped that name generator. And then we're like, okay, but all these other name generators are super important and it takes a really long time. So we're having, it takes at least an hour just for the network portion of this survey. Fortunately, they get all their neuroimaging and clinical cognitive stuff done in the clinic within 2 weeks of when we go into their home to get the network data. But still, there's a bunch of other stuff that we want to collect, right? Besides just networks. So how do we get these big networks without a lot of burden? And the problem we found wasn't sort of the average, right? So our average network size in the study with those name generators that I talked about, minus the elastic ties, is about 13. And so it's burdensome, right? But it's not horrendous. The problem is that we have these outliers. We would have older adults who would name 40 ties. And our interviewers would be like, oh my God. You know, I mean, just like, and then of course there's a story to go with every single tie because these are older adults. And so, you know, we had some of the outlier interviewers were like 3 hours, right? Just for the network part, for some of these people that named like a ton of ties. And then of course you see, of course, the attrition to the mean, right? Because they're like, okay, well next time I'm not gonna name this many ties. And we really want to avoid that panel conditioning, right? From a methodological standpoint. So we figured out, you know, we have to do something to reduce the burden, especially for these people who are sort of on the north side of the mean network size. So what we did is we did some analyses, and then there are different strategies, right? So I guess I'll start here in terms of like, what can you do to reduce respondent burden? I have no idea. How am I on time? Oh, cool, okay, perfect. So there are a variety of strategies you can use, right, to try to reduce respondent burden. So you can only collect information about core networks, right, which is sort of what we did in the pilot because we had a limited amount of time. And that's fine if what you're interested in is social bonding, right, because turns out like those measures don't differ much because those are based largely on what's happening in the core. But if you care about social bridging, which you may not, right? So like maybe 75% of you right now are like, I don't really care about what you're talking about bridging. But if you care about cognitive outcomes, and maybe I would argue things like achievement or advancement, right? Access to social capital where novelty is important, then you probably do care. You probably don't want to just collect these core networks. And then another option is to cap the number of ties. Which is what they do in InChap. It's what they do in UCI nets, right? No, not UCI nets. What is the freaking Claude Fisher study? UC nets, yeah? Okay, feedback, people. I need to know. I'm getting older. I'm experiencing these symptoms of cognitive decline. And so turns out that capping the number of ties is really terrible. That is like the least good solution, honestly, for reducing respondent burden, because there are just these like massive biases in the order in which people name people, right? So if you ask them who do you talk to about important matters and you cap it at 5 or whatever, they're gonna, they'll probably start with their partner and then they're gonna start with another family member and then all you're gonna get are family members because that's like how your brain works, right? You associate, you have these cognitive heuristics. And so Matt Brashears has done work on really, really excellent work on cognitive heuristics and how that affects network methods. But so, and then we've done a little bit of work with the InShap data, and they're capped at 5, and there's just like no variation on bridging. I mean, there's like just none. It's really, really bad. I mean, ours is a little bit better because we allow them to free, we don't cap the number of alters, so we do see some variation there. I think, I don't know. It's like relatively normally distributed. But if you cap, you get like no variation on bridging. So that was definitely not a good solution for us. So then we thought, well, let's try like randomization, right? So randomly selecting alters. And you could randomly select alters to ask about alter attributes. We didn't do that because our networks are not that big that it's like super, super burdensome to ask about alter attributes. But we did want to use it for alter ties. Because those are super, super burdensome and boring. And there's just not a really great way to collect them without someone wanting to like stab themselves in the eye. So, and this is the relationship here between the size of the networks that you're collecting and then the number of alter ties that you have to ask about, right? And it's huge. So, if you're asking about 20, if you're getting an average network size of 20, people are answering an average of 190 questions about alter ties. So it's not great. And Chris McCarty has done some really cool work on this. But the way that he looks at networks is he gets people to name 45 people, right? He's like, that's your target, everybody, name 45 people that you know. And so he does these analyses and he finds that if you ask about like 10 ties, you're pretty good. Like if you randomly select 10 ties. But the problem is then you have a fixed network size, right? So we don't really know how this works. 1, with like networks that are smaller on average, and 2, with networks where you have a lot of variation in network size, right? Which is what, we want to make sure that this randomization would work in that case. So that's what we did. So this is work that was really spearheaded by my postdoc and now research scientist, Sayun Pang, who's like freaking brilliant. But so what he did is we calculated the network measures in the full sample, and then we randomly selected n alters from the full sample, and you'll see what this looks like. We used, well, so first we used sort of a simulation study where we took network characteristics of older adults, not at random, but we used the mean and central tendency from the UCNet study, which is sort of a general population study of older adults. And so we did that, and then we also use our SNAD data so that we can see how does this relate to prediction. So we have the full randomly select n alters, and then we calculate the network measures in the random sample. We do that 1,000 times so we can get all the nice inferential statistics around that, and then we can compare what happens when we do that. And so this just shows you, this is the SNAD sample. This is the distribution on network size in that sample. So the average is about 13, standard deviation of about 6.5. And you can see it's highly skewed, right? So there's that person way out there who made that interviewer super miserable. But there's like a fair number of people who are naming like 20 people, right? And so, once we're getting sort of to the north side of things, this is going to be rough, both for the interviewer and the interviewee. So what we did, this is the results for the full roster versus randomly selected alters. And so on the top, you can see the results for mean absolute error, which is essentially the difference between the error between the two measures, and then mean correlation of the two measures. And the nice thing is you can see this relationship. These are the number of randomly selected alters. And here we have a fixed network size of about 13, right? Or at least that's the mean. But in the simulation study, which I can show you if anyone cares, he also did this a bunch of times looking at different sizes of networks. And so, if the average network size is 5 versus 10 versus 20 versus 200, right? And so both the size of the network that you have on average and the number of alters that you randomly select from it really drives how good the data that you're getting from this random selection of alters is. And the bottom line is, if you don't care about any of this, to achieve a correlation between the two of close to 1, right? So essentially what you're getting from the randomization is basically as good as real life. You just need to randomly sample n alters, where n is the average network size. So don't say I never did anything for you. Because that's a really simple rule of thumb, and it's super nice that it worked out that way, right? So you kind of get to this point where, so like here we're dealing with a network size of 13, so if you look at the 13, that's a super high correlation. It's a really low error. We're good, right? And so if we look at different size networks and different numbers of randomly selected alters with these simulation studies, just randomly sample your mean network size, and then all these people, to the right are happy because they only have to answer, many fewer questions about alter-alter ties.
Can I ask just for information?
Sure.
So you're saying for the randomly selected that when you are asking about attributes, that you only select a random number during the data collection process?
So we do that for alter-alter ties. We've not done it for attributes because we're a little nervous, right? We totally could I could actually ask Peng to do that analysis about alter attributes. Obviously, it would be the exact same analysis. We just didn't do it because we weren't willing to sort of go all in on that. So it applies to alter ties. So yeah, so we use NetCanvas, which is amazing, you guys. I mean, I cannot plug this hard enough. Network Canvas. And we just have this, we actually ask them to program in a way to randomize. I think they're doing that for us. It's coming. They just got their grant renewed, so hopefully that will be sort of baked into the software soon. But right now we use sort of this other randomization approach, kind of a workaround for the time being. But it works actually really well. And then, yeah, we just ask the alter ties associated with those. Oh, because you're using it's a weird, they're on the screen and it's, yes, no, totally. So that was another reason. I mean, only somebody who uses the software would know, right? It's very easy to miss them if you have too many. Yeah, and so this was another, it was really helpful for the interviewers in terms of not missing them, yeah. But the good news is, if you missed some, it was probably at random and you're fine. right? So you can just cite this paper, which just got published, and just be like, this is cool, guys. It's no big deal. Okay, so that's all the formal stuff. I'm happy to answer questions. I know I went through things kind of quickly. These are my collaborators. They're amazing. I'm really bad at Photoshop. That's my attempt at Photoshopping people. Don't judge me. This is why I don't make my own graphics anymore. Yeah, so I couldn't do this without them. But anyway, so I'm happy to answer questions about this or anything else about ego networks that you might be curious about. Yeah.
I have a question about the studies. So am I correct that in the pilot phase, the participants were in like an institutional setting, but in the second phase, they're in community settings? Or?
Yeah, so, well, right, yes. They weren't like institutionalized.
But like in a nursing care
They
facility?
they come into the clinic. This is part of an
they were
ADRC.
outpatient visits.
Yeah,
Okay.
they were already coming to do all the neuroimaging and the cognitive testing and stuff. So there's like a lot of downtime between those things, and so we were allowed to like scurry in and like ask some questions and leave. And then we convinced them that it was
But
important.
they were all living in the community.
They're all community dwelling.
Great.
Yeah, they're all community dwelling.
Thank you.
Yeah. Mhm. Yeah.
So as you are working with older adults, I was wondering if you did any longitudinal work on experience with loss of members of their network. I would assume individuals that were more bonding focused would take a loss more seriously.
Yeah, more of a-
I don't know, have you looked at anything like that?
That's a really interesting question. So we do have those data because, of course, at follow-up, we asked them to name their networks again, and then anybody that wasn't named from the prior wave, we asked them what happened. And then, of course, like they're older adults, so like a fair number of what we get is death in terms of turnover. We've never done anything with like what that does to the structure of the network. I think it would be super interesting. Do you want to like come work with our data? Do you want to join my lab?
Yeah.
Okay, well, email me. You can do that paper. Yeah, you can write the paper. Yeah.
This is super helpful. If I'm going to new population and don't know average network size, how do you do that?
I would collect some pilot data.
Okay.
Yeah. Or, I mean, if you know the population, right? Like if it's high school students, there are enough data out there that you could, leverage like a pretty decent guess.
Okay.
Or you could do what we did, which is for the first, a year, I guess, 2 years or something of the study, we collected all the data and then
Okay.
eventually realized that it was a hot dumpster fire and we had to do something.
I have a question about, I know that in the one slide that you showed that there was differential effects on mental health and cognitive functioning, bonding and, sorry, the other one.
Bridging.
Bridging. But I was wondering if bonding would be indirectly associated with cognitive functioning through those mental health outcomes and whether you've tested that.
Yeah, we have not, and I think absolutely, because there is like, so the causation is hard there, right? Because there's a lot of research that when people realize they're cognitively declining, they get depressed, super depressed, and so we could disentangle the direction of causation with these data. I don't know that we quite have enough longitudinal data yet to do that, but I think that would be a super interesting paper, and you can come write it if you want. Hit me up. We have so much data, you guys. Yeah.
I also have a question, relatively simple, related to longitudinal. You showed the two graphs, one showing the normal participants who had much larger, more diverse networks, and those who had dementia, much smaller. This might not be answerable with the way the data is now, but I would assume that, at least in part, the size of your network would shrink after a dementia diagnosis?
Yes.
Is that something that you were testing for data?
Yeah, so yes, so we've looked at that in like a cajillion different ways. Because we often get the social causation versus social selection question, right? So we now have longitudinal data, so we can look at lagged fixed effects, and so the data there look really good, at least for the core ADRD measures, and that's like brand new. We just got that recently. But there's a variety of other things that we do. So we have, let me see if I have this. Simulation. No, I took it out. Okay. I don't have it. But basically, so Adam wrote this really nice paper. It's published. You could actually read it about whether networks are predictive of actual cognition versus subjective cognitive decline, right? And so I think one of the primary mechanisms through which you would theorize that someone gets diagnosed with ADRD and then their network shrinks is social withdrawal, right? Like there's stigma, depression, right? You know, et cetera. So we find that social network characteristics are totally unrelated to subjective cognitive decline. So you think you're cognitively declining, doesn't matter for what your network looks like, but they're strongly associated with actual cognitive decline. So that's one thing that we've done. We've also done a lot of work where we're trying to look at measures of social bridging that absolutely precede cognitive decline, right? And so, for example, we've looked at occupational complexity. And so we have, unfortunately don't have these slides either. But actually my amazing grad student, Max Coleman, just got published in Alzheimer's and Dementia, which has like an impact factor of like 20 something. But he found that, that occupational complexity in working with people is really strongly related with like a whole range of cognitive outcomes later, including subjective cognitive decline, including informants, ratings of cognitive decline, diagnosis, actual neurodegeneration. But occupational complexity in working with things and with data is not associated with cognitive outcomes at all. So there's something, I mean, and of course that's, you know, that was based on your longest occupation. So that's occurring prior to, you know, the development of ADRD and neurodegeneration. Like I said, most of these people are retired. So in like a variety of different ways that we look at this, and of course education is another way too, right? But that's hard to disentangle what's social and what's not social. But in a variety of different ways, the data are suggesting that your brain is like essentially primed for social input, right? And if you're getting it in this way, you know, it's associated with these better cognitive outcomes, but also with neurodegeneration, regardless of what your actual cognitive function looks like. So social bridging, you saw the brain measures, right? Social bridging is associated with essentially whether your brain looks good in terms of whether you're going to get ADRD eventually, like before you ever have ADRD and net of cognitive symptoms. So it is hard, but there is on the other side. Oh, and another thing is we are because we're following them, some of them go to like moderate ADRD, but at the start, they're all normal. They'll convert to like MCI, but someone who has MCI, like you would be interacting with them and you wouldn't necessarily know that they have any cognitive decline, right? It's usually people very closest to them that could tell. So these are also like early in the, but we do see, I mean, there's tons of studies on isolation among people and their caregivers when they get to that point of being like moderately or severely experiencing severe cognitive decline. Yeah. So it's something we'll have to watch, but we're going to have to follow them for a while because these people are pretty early in the trajectory.
Yeah, and I mean, in your own work, you've done some research on the kinds of social support networks and networks that people have when they're entering spaces of treatment or diagnoses, for example, and the story of like a social support network growing quite a bit in crisis preceding coercion or voluntary entries.
Mm-hmm. You're such a suck up. Just kidding. This is my buddy from Duke. We spent like a whole day together because I came and gave a talk here and like nobody showed up. It was amazing. It was the most humbling experience. But I got to hang out with him like all day. It was so cool. Sorry, go ahead.
We didn't talk about work that much, so.
Yeah, we talked a lot about podcasts and other things. Anyway, sorry, finish your question.
No, well, actually, I was just going to ask, like, if you can so my feeling is that the people that are in the sample have already experienced that transition, right? They're already in places where people have they volunteered to go in that, or they've been coerced into that. And so what about all the people who have different social support or social network setups to begin with, and they're experiencing cognitive decline, that might not necessarily lead them to diagnosis or to like these kinds of settings, right? So,
Yeah.
so it seems like the sample that you're looking at is biased, quote unquote, in a particular.
Yes, that's an excellent question. So it is a convenience sample, right? So I just want to correct like one small thing. It's not a clinical sample, right? So these people aren't coming to this clinic because they have ADRD, they're volunteers in a study. And so they do, once they hit a diagnosis, they do come in and give them care, right? But before that, the vast majority of the sample doesn't actually have any experience with treatment or whatever. But we also, we have a general population sample at State Representative Indiana called the Person-to-Person Health Interview Study. And we recently went back and interviewed them 3 years later and just asked like a huge battery of cognitive tests. We don't have neuroimaging there, but we have the cognitive testing. And we have networks, of course, because, you know, whatever, we are who we are. And we're seeing very similar things, similar patterns around bridging, where bonding doesn't matter, bridging matters in this general population sample. There are downsides to it, right? So they're not high risk for ADRD, which is a huge advantage of this clinical sample because you can see changes. Well, first of all, you see more changes. So like most of them have like 2 of the ApoE4 alleles, so they're high risk for ADRD, or they have like other familial risk factors, or they're just super old. And so you can see the conversion, and you can see the conversion fast, which is, you know, why they follow this particular sample. So that has its own advantages. But you're right, it's not the general sample. So it is encouraging that we're seeing the same sort of patterns in the general sample. I do have big concerns in general about, you didn't ask about this, what time is that?
It's 12:50, so you go back.
Okay, cool. Then I'm going to wax philosophical about how shitty all ADRD research is right now, and why we're like probably having a crisis around what actually causes ADRD, which is why there's all this money being funneled into it right now. So one of the big problems with our clinical sample, and you're going to be like, why did you just tell me all these things about this sample that's like deeply, deeply flawed? But whatever, I'm just being honest. One of the major problems is that, you know, at this ADRC and most ADRCs across the country, they only want people who can be scanned, right? They can go in the scanner. And they want pure Alzheimer's disease, right? So they want a specific kind of pathology related to the appearance of amyloid and tau in the brain, right? And they thought that they were doing a really good thing by doing this because they're like isolating the pathology. But then what ends up happening is if you can't get in the scanner if you have any kind of bionic parts, if you have any kind of mental illness that would make you anxious. They also eliminate people with like comorbid like cardiovascular risk factors, you know, because of the scanner, but also because, again, they want pure ADRD, they don't want vascular dementia or mixed dementia. And in fact, they kick you out of the study if you get vascular dementia. But in the real world, the vast majority of actual dementia that you see is mixed, right? Vascular and ADRD. And so I think that I have a feeling, and I'm actually submitting a renewal hopefully this summer, where I'm going to try to diversify the sample, include more minorities. So we have about 20% non-white, which for an ADRD study is like pretty fucking good, actually, sadly. But also like low SES people. So our sample is like very high SES. So they've not experienced a lot of like chronic stressors, which is why they get into the study, right? Because they don't have any indicators of vascular dementia. So I don't actually know if anything that I've told you today would hold in like the real world. Aside from the P2P stuff, but any of the brain measures, we don't have that in the P2P. Yeah, so it's a real problem. I feel like I was going somewhere with that, but I don't remember where. Yeah, it's like the classic shitty science focusing on like white, high SES, and then conclusions may not actually hold to the real world situation that we know and love. Yeah, sorry, Jen's had his hand up for like a hot minute.
So, I love this work, but I'm just curious if you have any substantive insight on what the bridging is doing that might be transferable. So all these people that don't have bridging ties, but have, you know, bonding ties where people really love them, where they like tell random jokes or like, you know, crank up a personality, get TV,
Mm.
What is the thing about
Yeah, yeah.
bridging that's actually creating the cognitive advantage?
Yeah, no, that's a great question. And so for that, you really have to dial down to like the level of interactions, right? Like what's happening in these interactions. So I feel like we did pretty fucking good going from like networks matter to like bridging matters, right? But what you're asking is why does bridging matter? Like what's actually happening in the brain on that, deeper level? And so what I suspect is so I'll tell you what I think is happening, and then I'll tell you about this RCT that I think like supports what I think is happening. So what I think is happening is that when you're engaging in conversations or otherwise interacting with people you don't know super, super well, and I think these can even just be like friends that are not people you are like with constantly, it's harder to interact with them, right? Like you're exercising your brain. Like I'm up here talking to you guys and I'm like fucking sweating. Like my brain is sweating. Like trying to figure out whether you think I totally suck, or how do you want me to answer this question, or what am I gonna say next, right? Like it's a lot of cognitive work, versus like you're hanging out with your partner, your best friend, your sister, you're sitting on the couch together, you're grunting, you barely have to talk to each other, you know exactly what they're gonna say next, you know what they think about everything, right? That is not cognitive work, right? It is no work for me to interact with my partner. I'm like, right, I already know, right? But when you're interacting with like anybody that's not somebody that you're like that close to, that's outside of your core network. And that's why I think, these mixed bridging and bonding, those still have the bridging benefits, right? It's just a lot of cognitive work. And so this, going back to that really messy, nasty graphic that I put up first, like things like, racial homophily, like bad for your cognition. Educational homophily, age homophily, bad, like, right? You want like age, you want diversity. And I really think it comes down to just interacting with people that have different accents, that use different language, that look different, where it's harder for you to read their facial expressions and their body language. Like on a cognitive level, I think like it's just literally exercising your brain. And so I work with this psychologist who's freaking amazing, Anne Crandall. And one of the big things that seems to be driving a lot of this, in fact, she just texted me earlier and said that theory of mind mediates 70% of the relationship between bridging and general cognition. This can't be right. It's too good to be true. But essentially, theory of mind is like, if you're a sociologist, taking the role of the other, right? And she measures it in this really amazing way by showing clips of The Office and then like asking like, what is Dwight intending here? Like, is there deception happening? Like, does Jim really mean this when he says this, right? And so that is a skill that goes quick in ADRD, right? It's one of the first things that goes, which gets back to the reverse causation issue that you were talking about, right? And so there's something, I think what we think is happening is it's exercising your theory of mind, right? It's forcing you to use theory of mind in a way that builds these specific areas of the brain that we know are associated with theory of mind, like the amygdala, right? And so we can use the brain data to sort of triangulate. Another really cool thing, and I love this woman now, her name is Hiroko Dodge. She used to be at UCLA, and I think now she's like at Harvard. She did this, she called me 4 or 5 years ago, and she's like, I'm gonna do this randomized controlled trial where I just have graduate students meet with these older adults who have MCI, right? So they're very, very early in the diagnostic trajectory. I'm gonna have them meet with these people weekly for a few months. They're gonna talk for an hour. I'm gonna show them a picture, and they're gonna talk about the picture. So it's like nothing important, nothing that matters. Different graduate student potentially every time. There was no attempt to fix it to the same person, so they're having some deep relationship. And she found in this RCT a significant, both significant in terms of the magnitude of the effect and statistical significance, benefit of these totally random interactions with strangers, basically, weekly, right? So it's not even that big of a dose. So that I think also is more triangulation of what may be happening here. So she and I are now working to try to do a bigger study. I don't know, trend. We thought one of my students came up with this idea of choosing a random contact from your phone and prompting you to contact them and have just have a 5-minute talk with them, once a day or every other day, right? I don't know. But it seems that easy, which honestly, like, is kind of optimistic. Like, it's really hard for me to, like, get you a new friend. But I can get, like, some rando to talk to you for, like, an hour, right? I can pay somebody to do that, you know? So in an intervention sense, it's actually, like, kind of best case scenario. But, yeah, anyway, sorry. You had here, yeah.
I was thinking of this in terms of like the whole, if you don't use it, you lose it kind of thing, and how studies that look at introducing physical activity to those who are not physically active is different than introducing physical activity to those who are physically active. So if you have someone who at the onset of the study doesn't do a lot of bridging versus someone who does a lot of bridging, and then later on how that changes over time, I would imagine potentially that those who don't do a lot of bridging benefit the most from like just one bridging time versus someone who's like actively managing these complex social networks, and then as they get older it gets so much harder. Maybe having that one time a graduate student come to talk to them versus multiple different graduate students coming to talk to them. But there might be different effects based on what they're cognitively accustomed to earlier on in their neuro.
Yeah. I think that's a great idea. We don't have the data to test that, but I think you're absolutely right, because every time we run an interaction where they're like, who does bridging matter for? It always matters way more for the people who are at high risk for ADRD, right? So it matters for people who are at high genetic risk. There's a gene environment interaction there. It matters for people who have low levels of education. It matters more for people who live in rural areas. So, you know, it could be that bridging is essentially compensating for other kinds of cognitive deficits that you experience in your environment. So I would 100% expect that you're entirely right. I just don't have the data to test it. Are we good? That's it?
Last question.
Oh, last question. Oh, God, I don't want to choose. Okay, sorry. I'll talk to you later. Yeah.
Sorry. So you were discussing the positive effects of bridging, but you also mentioned earlier that older people don't want to bridge.
Yeah.
How is there any research on how families and physicians should be encouraging this in older adults? Because my grandma does not want to make new friends.
Yeah, no, I know, it's a problem. Well, I mean, it's like kids don't want to eat their vegetables either, but like, you know. Yeah, it is a problem, and I think there are some introvert-extrovert differences there, and I do worry that if we're like, oh, the solution to this is just to go in and force you to interact with the people you don't want to interact with. Well, but like, right, yeah, like ultimately is this, I mean, so there's stress, right? And then there's distress and there's eustress. And when it comes to like brain development and neurogenesis, you want eustress. Like distress is bad for the brain, right? Stress is bad for the brain. So like, how do you walk that fine line between making people exercise their brain or getting them to exercise their brain and just inducing a bunch of like stress on someone? You know, and I think about this a lot when it comes to like disparities and racial minorities, right? So like, oh yeah, it's good for you to interact in a diverse network. Well, that's easy for you to say when you're not the only fucking one, right? So I mean, I think about this a lot. Not putting findings out there that are going to lead to like bad interventions. But in terms of like whether doctors are thinking, they're not thinking about it because I don't think they think it's bridging. I think they think any kind of interaction is fine. So they're like, just go interact with anyone, right? But I think that's wrong, right? So I don't know. I think we're kind of early days, really, with this stuff.
Truly fantastic. Thank you.